In this example, we're going to solve this separable differential equation and use our initial condition here to go ahead and find a particular solution. So the first thing we need to do to solve this separable differential equation is to get all of our y's with our dy on one side and all of our x's with our dx on the other side. One consideration you could make is you see that there's a 2 as a coefficient here and a 4 as a coefficient here. You could divide both sides by 2 to get rid of that, but I will encourage you not to do that in this case because we'll ultimately be integrating 2y. So instead of having y squared over 2, we can just say y squared, and that will kind of alleviate the issues of having to have a fraction here. So let's go ahead and change this y prime to dy dx, and then we can multiply both sides by that dx. Cancel here, and there we go. So now we're ready to integrate both sides of our equation. So we have the integral of 2y dy equals the integral of 4 times the sine of x dx. Well, as we already kind of said, the integral of 2y is just going to be y squared. And then the integral of 4 sine x, well, we can ignore the 4, and the integral of sine is negative cosine, and then the 4 just kind of comes back in. So negative 4 cosine of x plus c. Well, in order to find this value of c, we can use our initial condition. So this pi over 4 is our x value. The square root of 2 is our y value. So we can kind of plug things in. So y is the square root of 2 squared equals negative 4 times the cosine of pi over 4 plus c. Okay, well the square root of 2 squared is just 2. And negative 4, let's see, the cosine of pi over 4 is radical 2 over 2 plus c. Well, the 4 and the 2 here can cancel, and it gives me the 2. So it looks like 2 equals negative 2 radical 2 plus c. So c then is going to equal 2 plus 2 times the square root of 2. And lots of 2's there. So let's go ahead and plug that back in. So we have y squared equals negative 4 cosine of x plus 2 times the square root of 2. And we have a y squared here. We could take the square root of both sides to get the y all by itself and put it in an explicit form, but you got to take into consideration the plus and the minus and stuff like that. So unless you need to have this written in a particular form, having the y squared over here equaling this expression looks good.